length, area and volume scale factors. Just doing 3 example questions and a reminder. We get our length scale factor, which we call K, by doing a length on the copy divided by a length on the original. And that division will give us the multiplication factor to get a new length on the copy if we need it. We call that scale factor K, or length scale factor. The area scale factor we can get in 2 different ways. We can get it by dividing an area on the copy. Now that's area or surface area, it doesn't matter, divided by an area on the original. So that dividing out 2 areas will give me the area scale factor. But we know from previous lessons that the area scale factor is the same as the length scale factor squared, or K squared. So I can get the area scale factor by finding K and squaring it to get K squared. And in the same way, I can find K, the length scale factor, by finding K squared and doing the square root to get K. So I've got options for finding K or K squared. What I really start with is finding out what do I have 2 matching values for. Do I have 2 matching values for length? I'll find K. Do I have 2 matching values for area? I'll find K squared, the area scale factor. And of course the volume scale factor I can get by doing a volume on the copy divided by a volume on the original. Sorry, these should be of, not on. The first one's on. Terrible English. There we go. And I seem to have missed the writing here. Alright, really dodgy there, sorry. My pen's not happy. Now, I can get the volume scale factor that way, but we know of course that the volume scale factor is the same as K cubed. Sorry, writing's not appearing. There we go. So I can get the volume scale factor by doing the division of 2 matching volumes on the copy and the original. Or I can get it, and my diagram's going to get confused, by cubing K and I can get back to K by doing the cube root of K cubed. So a very complicated diagram. I can easily go between K and K squared, or between K and K cubed. If I want to go from K squared to K cubed, I've got to go back through K. No connection here. So that's another look at how they interact. Now, if you feel like it, we're going to look at 3 example questions which I have pinched straight from your textbook. The first one is a little bit tricky because we don't have any numbers. We've got one number, that's the area, surface area. But we're going to have to get our scale factor from a ratio only. And the way we get this is I can see that the little cone is half the height of the big cone. Now I don't know if the little cone's 10 and the little big cone's 20, or maybe the little cone's 1 and the big cone's 2, but I know that whatever it is, the little cone is half the big cone. And that's all I need to know. The lengths are what was given in a ratio. If that's x and that's x, eventually they turn up, then the little cone, which is the copy, now I'm using k, they've given me lengths, k, the little cone is x, and the big cone is 2x, and there's an invisible 1 in front of the x, and that simplifies to 1 over 2, which supports us in saying that the little cone is half the length of the big cone. But that's how we get k without length numbers. Pretty tricky. So I've got k, and I need to find area, which means now total surface area still works with the area scale factor, so I'll need k squared. K squared is a half k squared. Now remember, when I square a fraction, I don't actually need to grab my calculator if I don't want to. That means the top squared over the bottom squared. 1 squared is 1, 2 squared is 4, so k squared is a quarter. Don't need a calculator. Then, once I've got k squared, that lets me find the area of my small cone, and we're finding total surface area, and it's k squared times the large area which is a quarter times 840 centimeters squared. And if we're not feeling confident, we can do 1 divided by 4 to work out that a quarter is 0.25, and of times, we've still got times there, a quarter times 840, 210. We're still in centimeters squared, and it was a word question, so I'd say therefore TSA of, that's total surface area, of the small cone is 210 centimeters squared. So our steps are: find any scale factor, whether it's k, k squared or k cubed, find the one where we've got a pair of values, get to the scale factor that we want to answer the question, and use it. So we will go well over 10 minutes for this one, but if you get bored, stop. It's just you might need some of these examples. Question 6b is finding the volume when we've got two areas given to us, and I've got the messy writing, I'm sorry. So we want to find the volume of the larger pyramid, and they've gone and overlapped things again, which is very annoying. But they've given us two sets of the surface area. So given that we've got the surface area, we'll be finding k squared. Area on the copy divided by area on the original. We work out what the copy is. We want to find the volume of the large pyramid. So the big one's the copy, It's got a surface area of 288 centimeters squared. The small one's the original, 200. And with nasty large numbers in my fraction like that, I'd probably see what happens if I evaluate it. 288 divided by 200. Not too bad. K squared is 144. If it was horrible and complicated, I'd leave it as a fraction. Now, that was K squared. I need to find volume, which means I need K cubed. But I can't go straight from K squared to K cubed. I've got to go back to K by doing the square root of K squared. Oops, that's 1.44. Very careless of me. And the square root of 1.44, don't actually need a calculator, but let's just use it in case we're feeling nervous, is 1.2. Now that's got me back to K. That's length scale factor, but I need K cubed. So to get K cubed, notice how every time I'm finding something different, I leave a space, so it's obvious that this is a new sum. K cubed is 1.2, and we'll cube K, obviously. And we use to the power of 3. I'm just cubing my answer there. And I've got K cubed equals 1.728. So that's my volume scale factor. And now I do exactly what I did before. When I've found my scale factor that I need, I multiply it by the value that I know on the matching shape. So the volume will be K cubed times the volume of the small pyramid. I don't really need to write that line, I'm just showing you what we do. K cubed was 1.728 times the volume of the small pyramid was 1000 centimeters cubed. Put the units in because that's the units you're going to have anyway. And multiplying by 1000, don't grab the calculator, you know that we can jump 3 spots on the decimal point. 1728 centimeters cubed, and that's the volume of the large pyramid. Write that as a word answer, but this is taking forever, so we'll just move on. Okay, scrolling to my third question. Excuse me, there we go, get my calculator back. And our last one is just another example of a type of question that's in the textbook, where you don't have to find a value, you just have to find a ratio. They're asking what's the volume ratio if this is a scale model of a truck at 1 to 27. Now that does need the knowledge that 1 to 27 is the length ratio. Anytime they give you a ratio for a scale model or for a map, it's a length ratio. Now if that's K, K can be given as a ratio. So it's kind of like saying, excuse me, just hitting pause. Sorry about that. This is the length ratio. Now remember, we can always say that this is copy to real life anytime I see a ratio. And if I was going to do K, well, it's copy over real life. So I can turn a ratio into a scale factor by turning it into a fraction. I don't need to do it for this question, but it might make you feel better. I want the volume ratio, so I want k cubed, so that will be 1 over 27 cubed. And I do recommend we keep this as a fraction. That's 1 cubed over 27 cubed. And I want to keep it as a fraction because I want to get it back to a ratio. I don't want a decimal. 1 cubed is 1. 27 cubed, well, 27 to the power of 3. Really nasty big number. 19683. And that is copy to real life for volume. And you saw that a ratio would just get to be copy to real life, and that's my volume ratio. Yes, it's kind of gigantic. That's the point. Volume increases massively compared to length in similar figures. Sorry about the really long video, but that's 3 questions that I've helped out with now in exercise 8G.